Hello guys, I welcome you to VMS Projects Limited, where we design and build classic homes. Welcome back to site.
Now I talk now, say normal you supposed to look and punch, you no go feel on.
See where we are right now. We've done so much already. I tell you guys, and I keep telling you guys, that any project without challenges, I don't know how it is. It doesn't excite us. But on this project, we have a whole lot of challenges. And one thing with challenges is challenges make us grow. So most times when we face these challenges, we learn more, we get to improve more. So the water table on this project is so high. It is so high, and it's a crazy situation. But thank God that we'll be able to, have responsive solutions to that. So guess what? On this episode, we'll be discussing the inverted T reinforcements. Thank God we have our structural engineering consultant here today with us. So he'll be teaching us and be giving us the insights to his design and what that he suggested for this design and why we are doing what we are doing. So after now, we'll be listening to him and he will give us a lowdown of information that we need to know about the Raft Reinforcement Details.
First of all, we did a lot of considerations from the soil test report that was sent to us and the depth at which we are going to go for this for the raft foundation option that was given to us from the soil test report. This type of foundation was chosen because of the cost effectiveness of this type of raft foundation. Now, doing the normal mat foundation for this kind of foundation for this project will work, but the costs, that is why we adopted this style of foundation. If you can see around the spacings for the stirrups, the inverted T base we have for this is just to increase a level of balance, have a level of balance at the base of the raft beam. That's why we adopted this style. Now, meanwhile, we would have used the mat foundation, but because of the loading coming on each column point and the axial loads coming from the points and the stress from the soil is a little bit quite comfortable and we can work with it. That's why we adopted this style of foundation. If not, the water has covered everywhere. We'd have seen the base is an inverted T, a width of 800 mm T base with a flange, with a web. The flange is bottom at 800 with a web of 1.2 meters web. This is this place. The flange is at the bottom. This is the web of the beam. From the soil test report, they asked to go a depth of 600 mm to 1 meter for a stable soil bearing capacity that we use to design this type of foundation. That's why I went for 600 mm depth. So at 600, we got a very stable soil, though we are having a little bit of groundwater and rainwater challenges. But the groundwater challenge is not so much as the rainwater challenges we are facing currently on site. But for the groundwater, it has been covered and it has been solved. So that's why I went for 600 mm depth. If this was a steel beam, it would have been a T flange, a T section of a beam. But now we adopted that T section steel beam as concrete because the base is where the tensile stresses of this beam is coming to. Okay. The compression is at the top. The tensile stresses is coming at the bottom of this beam. That's why we have a wider base and more reinforcements at the base of this inverted T raft foundation we are adopting for this particular project. Had it been the water has not covered the base, we'd have seen 16 mm at the bottom zone, then 12 mm side bars, then 16 mm top 316 mm top bars. So the bottom we're having 5 to 8 16 mm bottom bars for this place, just to cater for tensile stresses coming from the column points.
Now you've heard from the structural engineer. I hope you learned one or two from him. That makes so much sense. So now the next line of action for us today is to prepare for the casting, because we're going to be casting in two phases. The first phase is the casting for the base of the inverted T, then after which we'll board and do the beam casting. So for now, the same challenge we had there on the blinding, before we even finished up with the reinforcements, the rain that fell for like 3 days consecutively, filled up the whole trenches again. You can see from the videos, you see how the water has covered everywhere. So that's another challenge on us. So we had to bring them in the water tank for them to come flush this water for us, because there was no area that we can even pump this water to. Even our pumping machines weren't doing so much work again. We had to involve like 3 pumping machines, but they weren't working. Even with that, the volume of water was just so much. So we had to get a 12,000 liter tank to flush this water out. So the idea was for it to come, drain the water, and go out and deposit it anywhere, then come back. So we had to do that 12,000 liters of water tank. We had to flush about 5 to 6 times before we were able to get a reasonable area to work with. So that challenge also broadened our horizon on what to expect, when things like this come up. So by the time we brought in those tanks, we were able to flush a reasonable number of the water, and after that, we were able to do our casting. So the casting was successful, as you can see. So our electrical and mechanical engineers are not left behind. They are also on site today to supervise the installation of their mechanical and electrical machinery and systems. The electricals are also, ensuring bonding and contacts of the reinforcements for lighting and earthing. They're also here to bring their technical expertise and knowledge to create a functional, safe, and efficient building. So the next line of action for us to do is to start up the boarding immediately. So the boarding system we always adopt is we use marine boards. That marine board has many advantages. At the end of the day, see how smooth the surfaces of the beams will be after the casting. So we involve the marine boards. After the carpenters you can see how the carpenters are working, trying to set up the marine boards with the brazing systems and all that. So by the time we finish up with the whole carpentry work, then we get ready to cast our beams. So casting our beams, by so doing, we've already get up from the stage we had water, so we don't have so much issues with water again. So you can see how we've been able to cast our base, and you see how neat this casting is. It is so amazing. So I appreciate you guys for following us. On the 4th episode, we'll be discussing the filling of these raft beams, the filling, the watering of the filling, the compaction, the mats that will be on top. Will give you another reason why we left a portion on the beam, the reinforcement portion, where we can connect the beams to the mat before we do our oversight concrete. Thank you so much for following us. On that next episode is going to be amazing. So I want you guys to follow us. Make sure you're following us. If you're not following us, you're on a long thing. So you folks go back to our pages and follow us and see the next episode. And I am very glad you'll be surprised that at the end of the day, you will love what you see. Thank you very much. My name is Victor Zubinge. God bless you.
VMS Project Limited, building right all day long.